Hello, everybody. Welcome back to Numerical Methods lectures. Today, we're going to talk about subfunctions, inputs and outputs, and working towards a little bit more flexibility in our coding. So at this point, hopefully you feel comfortable with the structured programming that we talked about last time, basically if statements, logical operators, loops, and whiles. This makes up a majority of how we're going to actually carry out a desired task in MATLAB. Today, I want to switch gears a little bit and talk about things that are going to simplify our life. So, namely subfunctions, which will allow us to sort of simplify the main text in our code, function operations, reading from files, and asking for information. So a subfunction, as the name suggests, is a secondary function within the main set of a code. Right? So when you create a function file, you can have not only the primary function, but one or more subfunctions. So that primary function is there to sort of give the general outline. And then subfunctions are really useful if we're doing a task over and over again, or there's a specific task that needs to be done that's a little bit complicated, and it's taking up a lot of space in the main flow of your thought process. As we get to more complex coding, we may want to send certain aspects of a code, such as calculating the answer to a quadratic equation, into a subfunction, and that way we don't have to see 3 or 4 lines of code over and over and over again through our main function. So let's look at how we can actually do that. So I've written out here sort of just a general scaffold. We can have our main function that's going to say by called main function. We can carry out some set of operations, and we're normally going to see these pop up as loops or conditions, and then it's going to call a subfunction. And then it will come to the end. We then write a secondary function call after this end statement, and you really have to have that end in there, or else MATLAB won't know how to operate. So then after that last end statement of the main function, we come in and we write a new function call. So this time maybe function A equals subfunction B. And then we have just, once again, our list of mathematical operations that we want to do. So pretty straightforward once you have that understanding of how main functions are going to work. So let's do an example. So we're going to have in MATLAB. So here we're going to take our water gas shift reaction and turn it into a main function and a subfunction. All right, so here we are back in MATLAB with that catalytic water gas shift conversion function that we had finished last time. So we can see that this code is already getting a little, there's a lot to look at, right? We have this whole section up top that's dealing with calculating k and then calculating x0, so all this stuff that's going into the quadratic, and then we're doing the actual work of the code, or a lot of complexity in with this looping. So to help handle this, we can do a subfunction. So I'm going to just put in here as a comment, calculate, whoops, here's maybe a subfunction, calculate quadratic formula. Okay, so I can take all of this stuff out. And I'm going to come down here after the end of my function, and you can tell that this is the last end because you have these handy minus signs that will collapse that function down to the end. I can go after that last end, so I can come down here and generate my new function, I'll write function x equals quad. I will take an a, b, c, and then a indicator to say whether we want the plus or the minus. We can call this PM for plus minus. Close that off, and then we write in that end for that subfunction. So here, once again, we're going to need to have that end when we have that subfunction. Okay, so now I can just pop back in the code that I previously had. So here we calculate that x1 for that quadratic one we're positive, or with the addition, x2 for the minus, and then we can take into this PM case via an if statement. So if PM is equal to 1, we'll call it x equals x1, else x equals x2. End. Okay, so now we have our quadratic function. This is all that same information that we had stored, had done before, just all wrapped in this function. So now, up here where we do calculate quadratic formula, I can just write x0 equals quad a, b, c. And in this case, remember, we wanted the negative case, so we'll put in, say, -1. That'll tell that subfunction to use that else statement. Right? And so now this function is going to operate just like we did before, but we've used before. I'm going to actually go in and change this this name because MATLAB already has a function called quad. So we'll just call this calquad. That way MATLAB won't get confused. All right, so now we're ready to go. You can see we've reduced the size of that quadratic formula in the main area down to a single line, so that we can see better how our code is going to flow. So we can save that, go in, calculate t maybe from 300 to 700 in increments of 50. Now we can call that new code, and it works just the same as it did before, but we're now using that subfunction. So really, things that we're going to want to do lots of times, or we know we want to write a chunk of code, make sure that it works, we can do that using a subfunction. So anonymous functions are another similar feature to subfunctions. These are cases where, or these are useful when the commands or the math that we want to do fall onto a single line. So usually cases where we don't have if statements or loops. So let's say I wanted to write a function that's going to double, right? I need to double a value over and over again. I could write an anonymous function f that's going to take in x. So this, we have this parentheses and the @ sign, which means take in x, and then it's going to do the math afterwards. So this is the math or the operations that are going to be done. Right? So if I were to type in f of 2, MATLAB would return 4, right? So just like any sort of function, sine, cosine, right, we can put in there, and it's going to will do that out. I can take in multiple variables. I could do at x comma y. So it's going to take in both x and y. So these are once again the variables to take in, and then the operations. So we can do more with this than just have it set as an inline subfunction. The reason why is we can use this function to grab information that's in the function or in the script that we're already using. So let's say I have y already set to y equals 7. I can then build this function call at x to the 2 squared plus y. What this is going to do is it's going to build in this as a permanent 7. Okay, so x can change, but y here is a permanent 7. So if I were to do, say, fh comma 2, MATLAB would return 2 squared 4 plus 7 would be 11. Now, if I reset y to 5 and I do fh of 2, I'm still going to get 11 because that y in this piece has been permanently set to 7. I would have to go back in and reset that function call in order to change that y in that function to a 7. We could do this, for example, z equals fh2, and we'll get that same 11 back. The nice thing of these anonymous functions, in addition to letting us sort of write these shortcut subfunctions, is we can pass these function handles to other functions. So we can write a simple function and then take it and send it into something maybe called find max that would find the maximum value of that given function given a value of x. So we can do quite a lot with these functions. So let's take an example. So when I pass these functions to another function, it's called a function, right? It's a function operating on a function. Right? And so this is going to be very useful as we move through the rest of this course, because we're going to be building functions that are going to operate, that we want to operate rather generically. So let's say we want to calculate the maximum value of a function, say the water gas shift function. We could then write a function that will return, say, x, which is the maximum, equals to, maybe we'll call this find max. It can take in an anonymous function f, and then maybe say the beginning, where we want to start looking, where we want to end looking, and the range over which we want to look. So maybe say the number of intervals. So then in this function, all we need to do is generate our list of variables. So maybe in this case, if we're going to think about doing this with the water gas shift reaction, we can call it maybe T. We can then say make the line space A, comma B, comma N. And then we have our list. So we can just say y equals f of t. And this f is going to be that function that's going to come in here. Okay? Now we just need to find the max value, so we can just say x equals max of y, and then we're done. All right, let's put this into practice and see how we would send this function in. Okay, so let's write our find max function. So we start out with just the function call. We had our x equals find max f a b n. Always put in that end first, just to keep track of it. So then we had t equals linspace a b n. Then we had y equaled f of t. So right, even though this f looks like a variable, we traditionally dealt with that f as being a variable, here that's going to be a function. Okay? And so then we just need to find x, which we can do with x equals max y. All right, then we can save it, and now we're ready to go down and execute it. So here's going to be the trick. Here I'm going to show you how to do it wrong first, and then we'll show you how to do it right. If I just type in find max cat conversion, say 300, 950, and hit enter, I'm going to get an error because MATLAB isn't going to know that cat conversion should be sent as a file. It's going to look for it as a variable. So what we need to do is use that anonymizer anonymous modifier with that @ We put that @ in there first. Now when I click go, it will run and it will tell us that we have a maximum conversion with x being 0.835. So the key thing with these anonymous functions and passing functions is to remember that we want, we need to have that @ in there that's going to symbolize an anonymous function or passing a function to something else. So the last topic that I want to cover in our sort of whirlwind pace of intro to programming is interactions with the command window or the screen. Oftentimes, or sometimes, we want to share information that's been calculated in a function or script to the screen, and then get input or advice from the user. So this could be, say, pick a new temperature, put in a mass, put in a coefficient of drag, lots of different things. And we can do this using the input command. So we tell MATLAB which variable we're interested in. So let's say n, and then we use set n equal to the input, close parentheses, and then some sort of prompt. So this is usually some sort of text. And we use the quotes to tell MATLAB that it should display the text. So for example, we could say n equals input pick a number and store that in n. Then in output, we could say, then we may want to display what just came in. And we can display something to the screen using this output. So we could either display a variable or text. So we could write display, or disp, sorry, to display text you picked. And then write display n. Right, so this would read in a number, store that number in n, and then write back out what number was picked and show that. So let's see what that looks like. So let's code that up. We have n, so this is obviously going to be a script because we don't have any function calls. N equals input, pick a number, display for our output, you picked, and then we can display again, n. Okay, so let's save this, and we can call this input output. When I click run, we see down here input output, it displays to us pick a number, I don't know, 5. Then MATLAB comes in and says you picked 5, right? So just like we saw this. So this can be used to help us in conjunction with if statements to help direct the program. So in addition to passing information into the screen or out of the screen, we may want to save data to a file so it's not just stored in memory. So we can maybe move it to a new location or keep it for next time. So we do this using the save command. So in either the script or the command line, we can put in save, open parentheses, whatever the file name is that we want it stored as, and then these list of variables that we want to store in. So if we do it just like this with just a file name, this is going to store it as a .m file. All right, so specific to MATLAB. To be a little bit more variable or useful and portable, we may want to save it as something else. So either a .txt for text or .dat for data. You can save it as pretty much anything you want. So to change how it's saved, you want to put in this period followed by whatever you want the end name to be. And then after you've put in all the variables, comma separated, we add this appendice open quote dash ASCII close quote parenthesis. So this piece here is commonly referred to as ASCII. It's a data file type going back decades, and this is how most data is stored in, say, a human readable format. So if you want to save, it behaves just sort of like those display functions. We give it a file name, what variables we want to save, and then if we want to save it as human readable, we do this underscore ASCII. So we can also load data from a file or read data from a file and set it to a variable. So instead of doing save, we call it load. We would say, we can either save it to a variable directly, so say a equals load file name.txt, or if we want that data to come in as the name of the file, we could just say load file name .txt, and that will then save, create a new variable called file name that will be saved, or will be input as a variable. Right? So there's a little bit more nuance as we get to more and more complicated file types, but this should be enough to get us going. Okay, so at this point, we've now covered all the material that we're going to cover on our intro to MATLAB. So from today, you should know subfunctions, function operations, reading from files and asking for information. But then from this entire section, you should know basic data input mathematical operations, dealing with loops and conditional statements, dealing with arrays and matrices, and now functions, subfunctions. So this is going to conclude the work for our first quiz, which will be coming up in about a week or so. So thank you and have a great rest of your day.